Lesson 56, angles in circles and circle relationships. When we talk about angles in circles, the measure of an arc of a circle is the same as the measure of a central angle. The measure of an arc of a circle is the same as the measure of the central angle. Okay, keep in mind, a central angle is one that emanates from the center. Okay, so the two radii meet in the center. So the arc on the outside of the circle is going to be the same as the measure of the central angle. If we have two arcs in a circle, for example, these lines open up to bigger angles. This arc is obviously bigger than this one here. The bigger arc is called the major arc. Okay, so the larger arc is called the major arc. Which means that the smaller arc would be called the minor arc. All right, let's talk about different parts of a line within circles. If we have a line that intersects a circle in two places, the line would be called a secant. All right, so a secant is a line that intersects the circle in more than two places. For example, get rid of my angles and arcs. If I have a line that intersects the circle at this point and at this point, this line is a secant of the circle. The chord is the part of the secant inside of the circle. And we can see that from the drawing over here on the side. As the line passes through the circle, passes through those 2 points, forming a chord in the circle. Now, the point at where the line and the circle touch is called the point of tangency. The point of tangency is where the line and circle touch. Now notice in my secant line, I have 2 points of tangency, one in the upper part of the circle and one on the lower part of the circle. Okay? So that's for a secant. Now, if we have a line that intersects the circle at only 1 point, the line is called tangent. Okay, so a line that is tangent is a line that intersects the circle at 1 point. Okay, so a line that is tangent would look something like this. If I had a line that was coming down here and it intersects the circle at this point and touches the circle, it is tangent to that circle. Oftentimes secants are the lines that go through the circle. Tangents would be the lines that go outside of the circle at some point. Okay, so know the difference between a tangent and a secant and be familiar with the terms chord and point of tangency. All right, let's talk about two concepts that we're going to use today mathematically. And I've got some examples drawn up here if you want to go ahead and take a moment to draw these examples out. We're going to write some rules and then an equation next to these examples as we work them out, and then I'm going to have you do a few on your own. Notice in the top circle, the blue circle, I have two lines that intersect inside the circle. Two secant lines with a point of intersection inside the circle. Notice the arc on the left is smaller than the arc on the right. The arcs and the angles are not going to be equal because we do not have a central angle of any kind. All right, so here's the rule for determining what those x's are. All right, now we know those x's have to be the same because they are vertical angles, but they're not going to be 40, they're not going to be 80. Here's the rule that we will use in order to solve for x. If two lines intersect inside a circle, the measure of the angles formed in this case, angles x, the ones we're looking for, is equal to it equals half the sum of their arcs. So anytime we see a circle and we have two lines intersecting inside the circle, the measure of the angles formed is equal to half the sum of those intersected arcs. All right, so if we look at our example circle over here, the intersected arcs that we have are 80 and 40. So what we're going to do is we're going to find the sum of those angles. Okay, so we're going to find the sum, which means we're going to add 40 plus 80, and that sum is equal to 120. Now, in order to find those angles, it's half that sum. So we're going to divide 120 in half, which means x is equal to 60 degrees, which means this x is 60, and this x is also 60 degrees. That rule applies anytime two lines intersect inside the circle. Okay, so for lines that intersect inside a circle, add the two intersected arcs and divide it in half to find the measure of your angles. All right, what happens if we have an example like the one on the bottom where I have two lines that intersect outside the circle? Here's the rule. If two lines intersect outside the circle, the measure of the angles formed is half the difference of the intersected arcs. Okay, so when they intersected inside the circle, we added to find the sum and then divided by 2. When we have lines that intersect outside of the circle, we are going to find the difference, which means we're going to be subtracting our two intersected arcs and dividing it by 2. Okay, taking half of those intersected arcs. So we're going to find the difference by subtracting 120, which is our bigger arc, minus 60, which is our smaller arc. 120 minus 60 is 60. And in order to find what angle x is down here, we're going to divide that by 2. And so x is going to equal 30 degrees. And that rule applies anytime we have an angle to intersecting lines outside of a circle. So inside the circle, add the arcs and divide by 2. Outside the circle, subtract the 2 arcs and divide by 2. What I'd like you to do now is go ahead and draw out these examples as best you can in your notes, and then go ahead and solve for x in both the purple circle and in the green circle, and we will check them in class.